Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick to the end of the problem where I have 3 bonus problems that are similar to this one which you guys can try to solve. Alright, so I have 2 to the power of x is equal to 0. Now, the first thing I'm going to do to solve this is I'm going to take the log on both sides because we're trying to find the value of x here. So if I take my the log on both sides, I get log 2 to the power of x is equal to log of 0. Now, if I have something in the form log a to the power of b, I can actually move this exponent b to the front, so this would equal b times log a. And the reason why this property is so important is because, let's say I have the equation 7 to the power of x is equal to 9. Well, right now, as you can see, x here, this is an exponent. And it's actually really hard to solve for an exponent, especially when the exponent is going to be a decimal. Because right here, 7 is not a whole, x is not a whole number, because we know that 7 to the power of 1 is 7, and 7 to the power of 2, this is 49. So we know that the value of x is going to be somewhere between 1 and 2. And now to find the value of x, if I use this property, and if I take the log on both sides, I get log 7 to the power of x is equal to log 9. Now, because of this, I can move x to the front. So I get x times log 7 is equal to log 9. And now that x is a real term, it's much simpler to solve for x. All I have to do is divide by log 7 on both sides. And now I get the value of x is log 9 over log 7. So that's why this property is really useful. So now for log 2 to the power of x, I'm going to be using this property and I'm going to move x to the front. So now I have x times log 2 is equal to log 0. Now, if we want to solve for x, all I have to do is divide both sides by log 2. These two cancel out, and I get x is equal to log 0 over log 2. Now, this is log 0, the value of that is actually undefined, and the value of log 2, this is 0.301. Well, because one value is undefined and you can't divide an undefined value with another number, this means that the value of x is actually undefined, meaning it has no solution. So x is undefined, so this equation has no solution. Alright, so I have 5 to the power of x is equal to 50. Now, the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 5 to the power of x is equal to log 50. Now, important property of logarithms is that if I have something in the form log a to the power of b, I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. So now log 5 to the power of x, I can move the exponent x to the front. So now I get x times log 5 is equal to log 50. Now, I'm going to divide both sides by log 5. So then these two cancel out, and I'm left with x is equal to log 50 over log 5. Now log 50, this is the same thing as log 10 times 5. Now I have this over log 5. And now if I have something in the form log a times b, this is actually equal to log a plus log b. So this is actually how you add logarithms. You simply just multiply the two bases. So in the case of log 10 times 5, that's going to equal log 10 plus log 5. Log 10 is actually equal to 1. So now I have 1 plus log 5 over log 5. Now log 5, that's actually equal to 0.699. So now I have x is equal to 1 plus 0.699 over 0.699. Now 1 plus 0.699, that's actually equal to 1.699. So now I have 1.699 over 0.699. And if you actually end up dividing these two using a calculator, you get that x is equal to 2.43. So that is our answer. Alright, so I have 2 to the power 49 times 50 to the power 50. Now, first off, our exponent 50 here, this is the same thing as 49 plus 1. So now I'm going to rewrite this exponent as 49 plus 1. So now I have 2 to the power 49 times 50 to the power of 49 plus 1. Now I'm going to be using an important property of exponents that states that if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So in this case, I have 50 to the power of 49 plus 1. So we can think of a as 50, m as 49, and n as 1. So this will get me 2 to the power of 49 times a to the power of m, so 50 to the power of 49 times a to the power of n, so 50 to the power of 1. Now, if I have something in the form a to the power of b times c to the power of b, this is the same thing as a times c to the power of b. So in this case, I have 2 to the power of 49 times 50 to the power of 49. Because both their exponents are the same, I can simply multiply their two bases and keep the exponent. So 2 times 50, that's going to be 100. So now I have 100 to the power of 49 times 50 to the power of 1. Now 100, this is the same thing as 10 squared. So now I can replace 100 with 10 squared, and I get 10 squared to the power of 49 times 50. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So 10 to the power of 2 to the power of 49, that's going to equal 10 to the power of 2 times 49. Now I have this times 50. Now 2 times 49, that's going to equal 98. So now I have 10 to the power of 98 times 50. Now, although we've pretty much simplified this as much as we can always just simplify more by simplifying this 50. So 50 here, this is the same thing as 10 times 5. So now I have 10 to the power of 98 times 10 times 5. Now, if you notice, 10 to the power of 98 and 10, both of these two have the same bases. And if two terms have the same bases, then you can always multiply them. So I can say a to the power of m times a to the power of n. This is equal to a to the power of m plus n. So in this case, 10 here, this is the same thing as 10 to the power of 1. So now remember, if I'm multiplying these two, I keep the two bases the same, and I simply add the two exponents. 98 plus 1, that's going to be 99. So I have 10 to the power of 99 times 5. So this is going to be my answer. And if you're wondering how big of a number this is going to be, this is actually going to be 5 followed with 99 zeros. So it's going to be 5 with 0, 0, 0, 0, and on and on and on. So that is our answer.